Alright, lesson 9.4 is about vectors, and our objectives are to describe vectors and solve problems that involve vector addition. So first we need to know how to add vectors. So if we have vector A, x1, y1, and vector C, x2, y2, if we add those together, all we do is add the two x values. So x1 plus x2, and then we add the two y values, y1 plus y2. And we put those little arrow brackets around a vector. So, what is a vector? A vector is any quantity with magnitude, and magnitude is just a word for size and direction. And a vector can be represented with an arrow. Okay, so magnitude. The magnitude of a vector is the distance from the initial point, or where it starts. So then the next word is the initial point. And the initial point of a vector is where the vector begins. Okay, so if the initial point is where the vector begins, then the terminal point of the vector is the point where the vector ends. And this is usually the side with the arrow. Okay, and a resultant vector is our final vocabulary term. A resultant vector is the sum of two vectors. Let's look into this a little bit. The magnitude of vector ON is the distance from its initial point, O, to its terminal point, N. So from the distance from here to here. The ordered pair notation for the vector is, so we're going to figure this out. So first we need to count the x values. So from the beginning point O, we have to go over 1, 2, 3, 4, 5. So the x value of this vector is 5. And then we have to go up 1, 2 spaces. So 5, 2 is the ordered pair notation of the vector. Okay, so knowing all of that, let's look at some examples. Example 1 says to describe vector OM as an ordered pair. Give the coordinates to the nearest tenth. Use sine and cosine ratios to find the values of x and y. So, first, we're looking at the angle 40 here. Let's find x first. So this would be adjacent, and we have the hypotenuse. So we're going to use cosine for that, because if we look at our acronym, adjacent and hypotenuse means we use cosine. So the cosine of 40 would be x over 80, which means we need to multiply this 80 times cosine 40, and we get about 61.28. Then we need to find y. So we're still using the same angle, but now we're using y, which is opposite, and the hypotenuse 80. So opposite and hypotenuse would be sine. So the sine of 40 equals x over 80. So we need to do 80 times the sine of 40. And if we type that in our calculator, we get about 51.42. So because point M is in the third quadrant, remember this is 1, 2, 3, and 4. And we know we've got positives to the right and up, and negatives to the left and down. So since point M is in the third quadrant, both coordinates are negative. So to the nearest 10th, OM is negative 61.3, comma, negative 51.4 with our error brackets. Okay, so that's example 1. Scroll down to example 2. Describe vector direction. A boat sailed 12 miles east, which is what's shown here, and 9 miles south. The trip can be described by the vector 12, negative 9. Use distance and direction to describe the vector a second way. So we need to find the distance from the starting point to the terminal point. So we're going to use the distance formula. So the distance would be 12 squared plus 9 squared. 12 squared is 144, plus 9 squared, is 81. And 144 plus 81 is 225. If we take the square root of 225, we get 15. So now we know the distance. The hypotenuse here is 15, okay? But we need to figure out the angle that it traveled at. So we were given adjacent and opposite. So if we look at SOHCAHTOA, adjacent and opposite means we need to use tangent. So the tangent of x, because we're trying to find the angle, is opposite 9 over adjacent 12, which is 0.75. So we need to use the inverse tangent of 0.75. And if we put that into our calculator, we get 36.869, or about 37 degrees. So this boat sailed 15 miles, about 37 degrees, and if we compare it to this horizontal line here, the angle goes down from the horizontal line 37 degrees, so south of east. Okay. Alright, let's go ahead and take a look at example 3. Adding vectors. Okay, so vector v is 4, 3, vector w is 4, negative 3. Write the sum of the vectors of an ordered pair. So to find the first coordinate of the resultant vector s, okay, s is just the vector we get when we add the two together. Add the x coordinates of v and w. To find the second coordinate of vector s, add the y coordinates of v and w. So if we add the x coordinates, 4 plus 4, and the y coordinates would be 3 plus negative 3. Well, 4 plus 4 would be 8, and 3 plus 3 would be 0, or 3 plus negative 3 would be 0. Now, on the second part, it says draw vector v using the origin as the initial point. So we're going to start right here, and we know v is 4, 3, so we're going to go over 4, up 3, and we're going to draw an arrow between those points. Now, it says to draw the vector w using the terminal point of v, so we're going to start here at the end of v and draw w. So we need to go over 4, and since it's negative 3, we have to go down 3, and we end up here, and we're going to draw a line between those 2 points. Okay, now it says draw the resultant vector s from the initial point of v to the terminal point of w. So you start at the beginning of V and you end at the end of W. Start here and end here where W ends. So if we do that, we just end up with a straight line from 0 to 8. And that is our resultant vector S. Okay, let's take a look at some of these check for understanding problems together. They're very similar to the ones we've already done. So it says describe the vector as an ordered pair, give the coordinates to the nearest 10th. Alright, so let's draw a triangle here because that's going to make it a lot easier to work with. This angle is 65, the hypotenuse is 51. We need to find x and y. So let's focus on x first. So if we look at x and we're using the hypotenuse, x would be adjacent. And if we have hypotenuse and adjacent, look at SOHCAHTOA, adjacent, hypotenuse, means we need to use cosine. So the cosine of 65 equals x over 51. So we need to do 51 times the cosine of 65 to get x. And if we put this in our calculator, we get about 22. Okay, then we need to find y. So y would be opposite of 65, and we're still using the hypotenuse. So opposite and hypotenuse would be sine. So we're going to use sine to find y. The sine of 65 equals y over 51. And so now we need to do 51 times the sine of 65 to get y. And if we put this in our calculator, we get about 46. Now, this is in the second quadrant. And we know that y would be positive up here, but x would be negative. So our point is going to be negative 22, or not our point, our ordered pair is going to be negative 22, positive 46. All right, let's look at number 2. For this one, we're going to have to draw a little picture for ourselves. A small airplane lands 246 miles east. So we're going to just say we start here, draw a line this way, 246 miles east, and from there we're going to go 76 miles north of a point from which it took off. Describe the magnitude and direction. So we need to find this distance and the angle that it flew at. So let's start by finding the distance. We can use the distance formula like we did earlier. So the square root of 246 squared plus 76 squared. And 246 squared plus 76 squared is 66,292. And the square root of that is about 257.47. Okay, so we found the distance, so the magnitude. Now we need to find the direction. So we're going to find this angle x. So we have opposite and adjacent sides. So if we look at SOHCAHTOA, opposite and adjacent means we need to use tangent. So the tangent of x equals 76 over 246. And since we don't know the angle, we're going to use the inverse tangent. So you're going to hit second tangent on your calculator. 76 divided by 246, which is about 17 degrees. So, our plane flew 257 miles, about 17 degrees and it flew north of east. There you go. Okay, last question, and it's just adding vectors. So we need to add 2, 3 plus -4, -2. So we're going to add the x values, 2 plus -4, and add the y values, 3 plus -2. 2 plus -4 is -2, and 3 plus -2 is +1. So our resultant vector would be -2, 1. Okay, you should have everything you need to go ahead and get started on the homework. If you have any questions, please do not be afraid to ask. I am here to help.